Good morning. I'm Akash Malik, and I'll be giving this demonstration on behalf of my team. What you see here is the simulator implementation that we have done, and the home screen basically comes with a default city. We have also added a park in the middle of the city with grass textures. We also have buildings with textures implemented on them. We also support panning, zooming, and changing the camera angle using the mouse. Um, in the edit menu, the user has the option to insert buildings. He also has the option to select existing buildings and delete them. The user can also move existing buildings, change their orientation, or even completely change the model of the building selected. We support 8 different models, and each of them have different textures applied on them. So we have a great selection of buildings to basically model a city. Then we have the light computation panel, which lets the user place different markers in the city. And these markers are positions on which light intensity calculation is being done in real time. So to show that these computations are indeed done in real time, we also have a sun simulation mechanism. In this, we are using a directional light and a starting and ending point. When the user hits the play button, basically we linearly interpolate between these points, and the light is and the direction of the light is basically position and direction of the light is basically changed. As you can see, these values are being updated in real time. Even in the 3D map, the height and the color of these markers basically represent the relative uh, intensities at these points. Next up, we have the shadow heat map calculation for the park. So the user basically starts computation, and the simulator basically starts collecting the heat maps over the period of time. And at the end, it will aggregate these collected heat maps using a union operation and generate a 2D heat map image here for us to interact with. Uh, these charts are labeled, of course, so it should be easy for the user to use this gizmo and the labels to find out uh, what and how these charts link up with the images and the 3D models. We also have implemented landmark visibility bonus requirements. So if you select a building, we highlight the buildings that are unable to see the selected building if it were a landmark. We not only show this information in 3D, but we also show it in 2D using scatter plot and a pie chart. So the scatter plot is basically the buildings that are unable to see the selected building. It is again on a 50 by 50 map because our scene is a 50 by 50 map. The landmark is here, and the inside buildings are buildings which can see the selected landmark. This is the percentage of the buildings which are unable to see the building. And as you basically change different buildings or select different buildings as landmarks, this value changes. Uh, for the sake of simplicity, we have pre-selected heights for different models from which we cast rays to find this measurement. This has been described in detail in the report. Next up, we have sky exposure, which fashions a similar mechanism for adding markers on the map. And as you can see, each marker computes the sky exposure at that point. This can be used to find out sky exposure of streets in the city. Uh, we did not add visual cues in 3D for sky exposure. Uh, that's done purposefully because it would be slightly confusing for the user to, again, like try to read values from here, since sky exposure is I would say, a value that might not be considered relative, and maybe its absolute value might be more useful. So we have color coded values here. Any value less than 25% any is shown as red. Any value more than 75% is shown as green, and anything in the middle is yellow. And as you can see, these points represent each marker here, and the value here basically represents the sky exposure at that value. The way we have computed this value has been described in the report in more detail. Uh, yeah, that should be all. Thank you for listening.